One of the first things that you'll need to learn when you're studying the trigonometry of real numbers is you'll need to learn what the pi values or the radian measures are on the unit circle. And I usually start with this in my pre-calculus course. And I really stress to students how important it is to just memorize the values. Well, really to understand where they come from, but then to get to the point where you know it well enough that you don't have to think about it very much. So first of all, the unit circle is just simply a very small circle on the coordinate grid with a center at the origin and a radius of 1. And if you think about the standard form of an equation, or the standard form of the equation of a circle, if I substitute in 0, 0 for my center, h and k, and a radius of 1, I end up with x minus 0 quantity squared plus y minus 0 quantity squared equals 1 squared, or simply x squared plus y squared equals 1. So this gives us an equation for all the points on a unit circle. And a lot of times we call those terminal points. So a little bit later on, we'll actually be putting ordered pairs to all of these dots that are around the unit circle. Now, a couple other formulas that you know for circles. You know area equals pi r squared. That one's not going to be real useful to us right now. But we also know that the circumference equals pi times diameter. Or you could say the circumference equals pi times 2 times the radius. And we could write that as 2 pi r. Okay, so if we're working with the circumference of the unit circle, which has a radius of 1, that tells us something kind of important. The circumference of the unit circle then is 2 pi. Now the approximation for that would be about 6 and 28/100ths. So that means that if you have a circle with a radius length of 1, it could be 1 foot, 1 inch, 1 mile, whatever, the distance all the way around the circle is 2 pi, or about 6.28 units. Okay, now we start with this idea, then we can find the other points from the portions of the circle. So if all the way around the circle is a distance of 2 pi, then halfway around the circle must be a distance of pi. So this is really half of the circle times 2 pi, which of course makes pi. And a fourth of the way around the circle, which would be corresponding to a 90-degree angle. A fourth of 2 pi would equal 2 pi over 4, which reduces down to pi over 2. Now you can write this as pi over 2, you can write it as 1/2 pi, or you could write it as pi over 2 and just say half pi. Okay, so a fourth of the unit circle equals pi over 2. Okay, now on the bottom, this would be the same as going 3/4 of the way around the unit circle. So 3/4 times 2 pi would equal 6 pi over 4, which reduces to 3 pi over 2. Now, a lot of times people will say that's 1/2 pi, or they'll put the pi on the top, 3 pi over 2. That's actually what I do. So 3 pi over 2. So 3/4 of the way around the unit circle is equal to a distance of 3 pi over 2. Now, I'll often have students go through and write the decimal equivalents for these. And pi, of course, is 3.14. 2 pi is 6.28. Pi over 2, if you go to your calculator and you just type in pi divided by 2, it gives you the decimal approximation of 1 and 57/100ths. Oops, let's go there. And then on the bottom, 3 pi over 2, if you do the same thing, 3 pi divided by 2 is 4 and 71/100ths. It's kind of good to know those 4 decimal approximations because it'll tell you when you change from one quadrant to the next. So if I asked you, what quadrant would you be in if you traveled a distance of 2 around the unit circle? 2 is going to be in between 1.57 and 3.14, so it's going to be right around in here somewhere, which would be in quadrant 2. Okay, now I'll also have students from this point go on and learn the middle values, which occur right here. Now, if you just look in quadrant 1, 1/4 of the unit circle gives you pi over 2. So half of that, which is really going to be 1/8 of the unit circle. Here would be the first eighth, 2/8, 3, 4, 5, 6, 7, 8. 1/8 of the unit circle is 1/8 of 2 pi. 2 pi over 8 reduces down to pi over 4. And of course, that's the same thing as taking a half of a half. So this location right here is going to be pi over 4. So this distance, that part of the circumference, is equivalent to pi over 4. Okay, now, if you go to the next one, we did pi over 4. Now we're at 2 pi over 4, which reduces to 1/2. Then go to the next one and we get 3 pi over 4. The next one down would be 4 pi over 4, which of course reduces to pi. Then we're at 5 pi over 4. Down here would be at 6 pi over 4, which reduces to 3 pi over 2. And then we're at 7 pi over 4. Back to the beginning, we'd be at 8 pi over 4, or back all the way around, I should say, which reduces to 2 pi. Okay, so the middle values, which correspond to the 45-degree angles, are going to be your pi-4ths. All right, now, next I'd like to look at these values that are left over. Now, of course, there's other values on the unit circle, but we just use these common ones to just understand the symmetry, and it really shows us how trigonometry works to model harmonic motion, and that would come up at a later discussion. Now, a lot of times I'll ask students, what angle do you think this is? And if you can see that that first quadrant, which is a 90-degree angle, is divided into 3 parts, you can say, well, that looks like a 30-degree angle. And then this would be another 30, and that would be the final 30. Okay, so if you think of how many of those little sections we have 3 in quadrant 1, 3 in quadrant 2, and so on. That gives us 12 altogether. So this is 1/12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now 1/12 of 2 pi is equal to 2 pi over 12, which reduces to pi over 6. So that first little distance there is equal to pi over 6. Now if I jump up to the next one, that would be the second one, so 2 pi over 6 reduces to pi-3rds. And then I get to the next one, which is 3 pi over 6, and that reduces to pi-halves. 4 pi over 6 reduces to 2 pi over 3, and 5 pi over 6. And then I'm down to 6 pi over 6, which of course reduces to pi. Now if I keep going, I'm at 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 is 5 pi over 3. And 11 pi over 6. And then we're back to 12 pi over 6, which reduces to 2 pi. Okay, now putting everything together. All the way around is 2 pi. Halfway around is pi. Half of that is pi over 2, and on the bottom we have 3 pi over 2. Okay, in the middle we have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Notice that those blue ones, 1/4, 3/4, 5/4, 4/4, 7/4, excuse me, they're all fractions that don't reduce. Really, the pi over 2 was 2/4 and it did reduce. So the blue ones in the middle are over 4 and they don't reduce. Then, the pi-6s. We have 1 pi over 6. Over here we have 5 pi over 6. On the bottom we have 7 pi over 6. And across we have 11 pi over 6. Notice that those 4, which are closest to the x-axis, are all fractions over 6 that don't reduce. 1/6, 5/6, 7/6, 11/6. All the other ones that had 6 on the bottom reduced. And the ones that reduced were 2 pi over 6, which makes pi-3rds, 4 pi over 6, which was 2 pi over 3, 4 pi over 3, and 5 pi over 3. So the four values that all have 3 on the bottom are closest to the y-axis. Okay, now one other thing that I didn't show you was that if you just go by those thirds, there's 1/3, here's 2/3, then we're at 3/3, 4, 5, 6/3. You got to skip over that middle pi over 2 to get that full third. So that's another thing that you can do to help remember it. Okay, now I usually have students go through and fill out a few unit circles. You can find unit circles on the internet. There's tons of great resources out there. We also will just practice. I'll ask students, where is 5 pi over 4? And they'll have to tell me that that's in, oops, I didn't mean to do that. That's in quadrant 3, and so on. Okay, now I'll just show you an example of one that's filled out. I found this on the internet and I just copied it over. The next podcast that I'm going to do, I'm going to show you how to find the terminal points at each value on the unit circle. Thanks for listening.